In this video I'm going to look at the solution to question 7 of the June 2010 Edexcel D1 paper. The topic of the question is linear programming. So the question starts off by telling us that Keith is organizing two types of children's activities, sports mad and circus fun. He needs to determine the number of times each type of activity is to be offered. So we're asked to let X be the number of times he offers sports mad and Y be the number of times he offers the circus fun activity. Two constraints are already on the diagram. X is less than or equal to 15 and Y is greater than 6. And we're asked to first of all explain why Y equals 6 is shown as a dotted line. And then the question goes on to say that there are two further constraints that we are to add onto the diagram in the answer booklet, and to represent these inequalities and hence determine the feasible region, labeling it R. Once we've done that, we're told that the sports mad activity costs £500 and the circus fun £800, and we're asked, Keith wishes to minimize the total cost. So we then need to find an objective function for C, the cost, in terms of X and Y, and use our graph to determine the number of times each type of activity should be offered and the total cost when we do that. In part A, we're asked to say why this particular line is drawn dotted, and that's purely because that the one constraint which we're given, which was Y is greater than 6, is a strict inequality. So as long as you say that, then the mark which was available for that part of the question would be given to you. So it's just a case of saying that this is a strict inequality rather than being greater than or equal to or less than or equal to, in which case a solid line would be used. We then have to mark on two other constraints. 3x is greater than or equal to 2y. So the way to do this is to first of all draw the line 3x equals 2y, so that will go through the origin, and we'll also go through a point where we have the ratio of 3 to 2. So for example, the very top point on of the graph there is at a value of 16 and 24. So at that point at the top of the graph we can see that we have that 3x is equal to 2y. So that's the line that we need, and we want 3x to be greater than or equal to 2y, so we need to shade out above the line, which would be the other part of the inequality. So just a nice neat hash line like that to show which part you're shading out of the diagram. The 5x plus 4y is greater than or equal to 80. Well, the easiest way of doing that is to look at points where the line 5x plus 4y equal 80 crosses the axis. So that would be at x is equal to 16, which is here, and at y equal to 20, which is here. So I've put that line onto the graph, and this time we want to keep the area which is above that line, so we're going to shade out below the line. So all of this area here would be shaded out, and that leaves us with the feasible region in the center bit here, so we need asked to label that R. Well, let's consider the mark allocation of those first two parts of the question. There was just a single B1 mark given for the explanation of why we had the dotted line in part A, and then there are a total of 3 marks for the next part. There was a mark for each of the lines, B1 and B1 for each of those lines, and then for the labeling of R. In the next part of the question then, we're looking at the cost, we're asked to minimize the cost, where Sports Mad, and this was X, cost £500 and Circus Fun Y cost £800. So we're asked to therefore minimize the objective function C is equal to 500x plus 800y. Well, on my diagram I've put one particular value of the objective function line there. This is where we've got x equal to 16 at one end of the line and y equal to 10 at the other end. So that would be C equal to a value of 8,000. But we can actually move the line now and see, if we're trying to minimize, we want the first point that this line enters the feasible region. We can see that at the moment we're below the feasible region, but we're going to look at where does it enter the feasible region. So just moving the line up a little bit at a time, we can see that we're getting close to the feasible region now, and it's entering at this corner at the bottom end here. Now remember that we must have integer solutions for this, and also we can't have a value which is on the dotted line, because this line here is y. We want y there to be greater than 6. So we've got to look at integer solutions somewhere around this point here. So we can't actually use points which are on the line, but so our closest one is this value here. If you look at the scaling on there, we've got therefore an x value of 11 and a y value of 7. You might want to check a couple of other points. It certainly can't be at 12, so this point here is not allowed, because y at this point here is equal to 6. So you might want to mark that on the diagram. Therefore our smallest value is going to be x equal to 11 and y equal to 7. So we can say therefore the minimum is when x is equal to 11, y is equal to 7, and then we get a cost of then £11,100. The marking for this part of the question, there's an M1 A1 mark for using the objective function, having got the objective function written down correctly, and 2 marks there, B1 and B1. And then finally an M1 mark for really considering these points here, and a value of A1 for our answer, and then a B1 mark for the final cost. Well, that concludes the solution to this question. You can find solutions to other questions on www.furthermaths.org.uk.